Hi everybody. So this video is intended to give you some insight into what I'm thinking as I read one of your formal proofs. So I want you to remember there is a very big difference between how you prove a result and how you write up a formal proof of that result. So you're going to see me crossing out a lot of words in the proof here, which incidentally is a correct proof, right? The author absolutely understands why the result is true, has given a compelling argument for why the result is true. We're just going to see that the author has written up, in a sense, too much. They've explained too many things. They've given too many indications as to what they're doing rather than actually just doing it. So let's jump right in. So first, easy thing to check, is the exercise written correctly? And sure enough, yeah, everything looks really, really good up there. So nothing to say up there. But let's jump down into the proof now. We're trying to show that two sets are equal, and so the author correctly points out that we need to show that those two sets are contained in one another. However, anybody who you could expect to be reading this proof already should know that that's how you show that two sets are equal to each other, which means that that line is superfluous. You don't need to say what we need to do if you just go ahead and do it. So we're going to get rid of this top line. All right, next we jump in here, and actually you can see there is a forward direction and a backward direction corresponding to the two inclusions that we're going to show. And again, that's superfluous information. When you're writing it up for yourself, absolutely you should write those things down. It's how you're going to organize your thoughts. It's how you're going to remember not to skip a step. But when you're trying to write up your proof in a formal way, you don't need to do that, what we call signposting. So we're going to get rid of these lines as well. All right, next we say suppose y is an element of f of a union b and it's arbitrary. Okay, and in fact you'll notice here, 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 the author's using this is arbitrary. This is redundant. As soon as I say y is an element of f of a union b, with no other indication as to what the element is, that means I'm choosing an arbitrary element, right? If it's not arbitrary, it's specific, and there's no specific way I can do it. So we're going to go back, and we're going to eliminate all those. Anytime we see an is arbitrary, okay, we can get rid of that. Okay, so now, suppose y is in f of a union b, since y is in f of a union b. Well, okay, there's no need to repeat what we just wrote. So we're going to condense those. Before we do that, let's point out something troubling to Dr. Glesser, which is we have here what's called a since-then construction. So Dr. Glesser does not like since-then constructions. In fact, anytime Dr. Glesser sees a then, he's looking very hard for an if coming somewhere before that then. All right? The if indicates the hypothesis, the then indicates the conclusion. So you don't want to use this construction, but we can really easily fix this problem by simply crossing out all this and inserting if. So it now reads if y is an element of A union B, which is really how we had started the sentence over here. Then, okay, so before the then, we'll put a little comma. Then there exists x in A union B such that f of x equals y. This is short, concise, to the point, gives us exactly what we want. Okay, we continue. Since x is in A union B, all right, again, we're repeating ourselves. We just said that x was in A union B. We don't need to necessarily say it again. So how about we just replace this since-then construction with, and here we'll do that in red, with it follows that. So it follows that x is in A or x is in B. Okay, now let's pause again and notice we have, for the third time in as many sentences, a since then. Now, I've already said I don't like the since then construction, but this is a different problem I want to mention. We're repeating the same language over and over, and if we look down below, over, 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 over. This sort of redundancy in language isn't mathematically incorrect, it's just really not fun to read. All right? It's very, very cumbersome, and it makes it so that it's oftentimes difficult to read because you have nothing to differentiate sentence from sentence. So we're going to try really hard not to just keep repeating. We're going to try to use different phrases. Now, it's really nice here because, well, we're going to be able to get rid of most of those since-thens anyway. But even if we couldn't directly, we would want to use different phrases. All right, well, let's see what we got here. Since x is an element of A, or x is an element of B, well, we just said that in the previous sentence, so we're going to get rid of that somehow. Then y is an f of A, or y is an f of B. Okay, why don't we just join it with the last sentence? It follows that x is an element of A, or x is an element of B. And hence, so we'll get rid of that and add in, and hence, y is an element of f of A, or y is an element of f of B, which implies, that's okay, it's not wonderful, it's fine. So we'll get a little comma here though, which implies y is an element of f of A union f of B. Okay, now the author concludes with thus, f of A union B is contained in f of A union f of B. All right, it's not completely necessary, but I like it being there. The only problem I have is we're going to want to take this line and we're going to want to move it up here. All right, there's no need to start a new paragraph for just that one sentence. Okay, now we'll go into the second half of the proof, this backward direction. Okay, so the proof is going to proceed in a very similar way, and so the corrections are going to be very similar. So, for instance, we're supposing y is an element of this union. Whoops. Well, we're going to delete it in a second. We're supposing y is an element of the union, and then we're saying since it's in the union, something follows. So let's again just dive back, erase this stuff, and just add in if. Okay, so if y is in the union, then y is in one of the component pieces. All right, now we go down and we can see some immediate signposting again. Okay, case 1, case 2. Now, if you look very carefully, you're going to notice that case 1 and case 2 are almost identical. All we've done is switched an A for a B. You switch it here with there, and then there's an A for a B. And there's an A for a B. That's it. Okay? There's no need to write the same thing twice with only a few minor modifications, which really aren't actually changing the idea of the proof. They're simply making sure it's, the bookkeeping is correct. So, a couple things we're going to do. So first, we're going to get rid of these signposts. Second, assuming that the first half is true, well, then the second half will also be true. So we're going to take all this and we're going to omit it. Now, you have to say something, okay? You can't just show one half, but what you can do is argue that similarly, well, what was the conclusion and the hypothesis? The conclusion up above was that y was an element of f of A union B, which is the same conclusion as down below. So we'll say similarly, y is an element of f of A union B. And what was the hypothesis? if, so originally it was y was in f of a, the next time it was in f of b, so we'll say if y is in f of b. Okay, so we don't need to have that entire case 2. Okay, let's look back at case 1, clean it up. Suppose y is in f of a, since y is in f of a. Okay, same thing. We can reduce this down to if y is in f of a, comma, then there exists x in a such that f of x equals y. Now we said, since x is in a, then, okay, we got that since then construction again. So how are we going to fix that? Well, there exists an x in a, okay. Well, how about we just say this? As x is in a, we have x is in a union b, and so y is in f of a union b. Okay? All right. Now, if we go down to case 2, well, we've already replaced that. Similarly, y is in f of a union b if y is in f of b. All right, now, thus by case 1 and case 2, we can just eliminate the reference to those cases and say, again, it follows that, or therefore, or hence, whatever we like. It follows that f of a union f of b is contained in f of a union b. All right, now at this point we're done. But we've repeated it. We've said hence, well, proves. Okay, that's just a language issue here, so let's get rid of that. We don't need any of this. All right, it's not hard to see what we've proved. Therefore, proves, well, okay, how about we just get rid of the proves, and therefore we get our conclusion. Okay, now if you look up, you see a lot of color, you see a lot of marks, but in almost all cases, right, it's just omitting things, or maybe some slight rephrasing of things. Now, how will you know what to do? Well, again, use my admonition that if you're talking about why something is true, it's probably best to leave it in. However, if you're saying what you're going to do to prove that something is true, that is likely to be something you can remove. Right? And the more you can remove, the cleaner your proof's going to be, the fewer opportunities you'll have to say something incorrect, and the less patient your reader is going to have to be as they go through things. All right, I hope this helps. Please let me know if you have any questions.